Assalamu alaikum, everyone. Today, the topic I'm going to cover is the correlation matrix. If you are given an interpretation of the matrix, but don't have the matrix itself in front of you, how can you use that word interpretation to reach a close to reliable or proxy table of the correlation matrix, to see how the assets or the variables that you have are correlated together, and to see a bigger picture from the given qualitative data. So the question in front of me is that create a correlation matrix with the following information for six assets: A, B, C, D. So I have six assets. From those six assets, I have to make a correlation matrix. How can I move from first step to the second step? Now, the first most important thing in any correlation matrix, and which is true for all correlation matrices, that the correlation of an asset A with itself will always be equal to 1. So covariance correlation of A with A will always be equal to 1. And this will be true for any other asset. So essentially the diagonals, A with A, B with B, C with C, D with D, E with E, and F with F will always be 1. So the first step for any correlation matrix is to say that these diagonals will be 1. Second thing we have to realize is the covariance of A with B will be same as the covariance of A with B, or if we want to say B with A would be same as A with B. So correlation of A with B will be equal to the correlation of B with A. Essentially, this correlation metric will always be symmetric. So in the first step, I'm going to make a triangular correlation matrix. So I'm going to fill in this part of the matrix. Once I've filled this part up, I'm going to use the same values to fill this part up. So in the first step, I'm just going to make a triangular correlation matrix. Once I'm done with that, I'm going to use the property of symmetry to fill this part up if I want to have the entire matrix filled up. Okay. So having said these two parts, let's look at the third part. The first point of information that we know is variable C is uncorrelated with variable D. Variable C is uncorrelated with variable D. The relation between variable C and variable D are in this lower part. We have this relation between C and D. They are uncorrelated. They don't move together. There's no intercorrelation. Thus, this is 0. So uncorrelated, these two things mean that variable C and D do not have intermovement, and the correlation will be 0. The next part of information that we have over here is variable C is perfectly positively correlated with variable B. Variable C is perfectly positively correlated with variable B. That means this would be 1. Perfect positive correlation means when B increases, so does C increase. When B decreases, C decreases in the same direction at the same time with the same magnitude. There is so much co-movement over here that it's like both the series have the same data generating process. And thus the values of the two series may be different, but the up and down, the change, the magnitude, the movement is the same for the two series. Now, this having said that B and C, the correlation between variable B and C is 1, is kind of saying that across the asset categories, if we know the variation correlation of any variable with either B or C, we can perfectly predict the correlation for the other variable. So uh, let's move on to the second statement, and I'll show you how to use this one. The correlation between B and C is 1, are perfectly positively correlated, and find these correlations. So in the second statement, what we know is, so we are done with the first statement. Now I'm moving on to the second statement. In the second statement, what we know is variable A is strongly positively correlated with variables B and C. Now, there are two qualifiers over here. First, we know that A moves in the same direction with variable B and C. The second thing we know is that this relation is strong. Now, from the correlation table, you can see that no correlation, the value of the correlation coefficient will be 0. But when this relation is very strong, positive, then this should be between 0.91 and 1. When it's strong positive, the value should be between zero point 0.7 and zero point 0.9. For moderate, it would be 0.51 and 7. For weak, 0.3 to zero point 0.5. And very weak, 0.01 to zero point 0.3. Very strong correlation, negative side is minus zero point 0.9 to minus 1, and so on and so forth. So over here, A and B are very strong positive correlations. So let's take a number between 0.71 and 0.9 and fill it over here. So let's take in 0.8, for example, which is between 0.7 and 0.9, indicating it's a strong correlation between B and A. Once we have established that the correlation between B and A is 0.8, we'll have to look at some other things as well. Consider some other factors. Join the previous information that we have to fill in the table. What we know is A and B are positively correlated. A and B are positively correlated. That is given in the second statement. From the first statement, what we know is that B and C are perfectly positively correlated. Now, this implies that as B increases, C increases. And as A increases, B increases, and B and C are positively correlated. So what this says is A and C are positively correlated. Once we have that A and C are positively correlated and B and C are perfect, so we can say that the correlation of A and B should be same as the correlation or the covariance of A and B. So whatever correlation I have set for A and B would be the same correlation for A and C, because there is a perfect relationship between B and C. So A, well, which mimics that A and B have a correlation of 0.8, then A and C would also have a correlation of 0.8. We also know from the statement that A and D are strongly positively correlated. So let's take another number, which is between 0.7 and 0.9 and fill it over here. So let's say 0.72. So correlation of A and D, we have assumed it to be 0.72. So we have filled out all the information given in this line. Let's move on to the next line. The third part, the third statement over here, which says variable E is very weakly negatively correlated with variable D. Very weakly negatively correlated. Very weak negative correlation is from minus 0.01 to minus 0.3. So between E and D, we'll have to set in a very, very small negative number. So let's say it's minus 0.03. So that's the only information I have here, and I'm done. In the fourth statement, what we are told is variable E is positively correlated with variable A, B, and F. Variable E is positively correlated with variable A, B, and F. Unlike the earlier situations, we don't know if this positive correlation is strong, medium, weak, moderate. We don't have any information. It gives us more flexibility. As long as the correlation between E and A, E and B, E and F is positive, we don't have to worry about what type of relationship are we talking about. We are not given that type of information, right? So all we have to do is focus on any positive numbers. So let's say E and A, I take one positive number, zero point 0.1. Okay. E and B, I take another positive number, zero point 0.5. Using the same relationship, if A and B are positively correlated, so E and B are positively correlated, B and C are perfectly positively correlated. That implies E and C will be positively correlated, and covariance of E with B and will be same as covariance of E and C. When I say covariance is same, then you'll expect the correlations to be same. So what we have is this 0.5 as well. So, so correlation would definitely be same. So having said that, we reach the stage where we have written in the relation for A, B, E with A, E with B, E with C because of their perfect positive correlation, and E with F. So E with F would be this box. Fill in this with another positive number, and we have this relationship. So we have extracted all the important information from here. And then let's look at the last piece of information that we give. A variable F is negatively correlated with variable A and B. F is negatively correlated with A and B. F with A should be a negative number. Again, does not matter which negative number we take in. A and F and B should be a negative number. Let's take a negative number. However, using the set type of reasoning, we know if B and F are negatively correlated, then C and F will definitely be negative correlated of the same amount. So correlation of B and F should be same as correlation of C and F. So we have the same amount. The last thing we know is F is uncorrelated with D. F is uncorrelated with D. F and D are uncorrelated simply means this is 0. Now you might notice I've left something over here. Do we have any information on B and D? there is no variable that connects B and D. Okay, so do we have any relation between D and C? What we have, variable C is uncorrelated with D. If variable C is uncorrelated with D, then variable B will be uncorrelated with D, and thus this will be 0. So we have our triangular correlation matrix. To make it into a tabular one, we'll just have to ensure that whatever is what is happening for B and A should be the same for A and B. So now 0.8 over here between A and B should be 0.8 over here for B and A. 0.8 of AC should be 0.8 over AC. 0.72 in AD over here should be 0.72 in AD. 0.1 in AE should be 0.1 in AE. Minus 0.01 in AF should be minus 0.1 in AF. Going about it in similar way, we can fill the entire table. B and C is 1. So B and C over here will be 1. B and D is 0. So B and D over here will be 0. B and E is 0.5. B and E over here will be 0.5. B and F over here is minus 0.5. So B and F over here will be minus 0.5. You can repeat the process and complete the entire table. In this way, we have our entire correlation matrix. This entire correlation matrix tell us better relationship than only the literal quantitative statements were telling us. We have assumed some values, but even with some values, we can see more relationships expressed over here in this correlation matrix than in those statements. I hope the whole process was clear for you. This was my first video that I've recorded for such a thing. So I know I made many mistakes. I was not very clear, and I'll be having many problems. But hopefully, I'll try to remove those problems as the time passes. Uh, please do comment if you have a problem in this video, and if you like it, please hit the like button. Thank you.